in case of product of two vectors, there are two types of products. We do not call it multiplication because multiplication stands for two numbers, two real numbers. But for vectors, we use the word product. First one is the scalar product, or it is also called the dot product, because if two vectors are there, A and B, we boldly put a dot in between them, and therefore it is written as dot. It's called dot product. Why it is called scalar product? Because the result is a scalar. The result is a scalar quantity. The result out of dot product of two vectors has nothing to do with any direction. Now, the other kind of product, this is called vector product of two vectors, or it is also called cross product of two vectors. If two vectors are A and B, we boldly put vector A cross vector B. This is the cross product. And the result is a vector. That is why it is called vector product, because the result is a vector quantity. So two types of product depending upon the result, whether the result is a scalar quantity or the result is a vector quantity. Based on this, the products are of two types. Now let's discuss a little brief about the dot product. Dot product A dot B, it is defined as the magnitude of the first vector into magnitude of the second vector into cos of the angle between the two vectors. So if I say the magnitude of the first vector is simply A and that of the second vector is B, so we can have AB cos theta. So it not only depends upon their own magnitudes, but it depends upon the cosine of the angle between them. So clearly, if vector A is perpendicular to vector B, then theta is 90 degree, cos 90 is 0, then the dot product will be equal to 0. Therefore, just observe I dot I will be, I dot I is, I means the unit vector along x-axis. It is magnitude of I, which is 1, again magnitude of I, which is 1, into cos 0. Cos 0 is 1. So therefore this is 1. Similarly, j dot j and k dot k, all are unit vectors. This is 1. And what will be I dot j? Magnitude of first, that is 1, in again 1 into cos 90, which is 0. So I dot j, j dot k, or k dot I, as all are perpendicular to each other, it will be 0. Therefore, dot product of unlike unit vectors is 0. Dot product of like unit vectors is 1, as you can see from this example. Further, you can understand that A dot B is same as B dot A. It is because ultimately the result has nothing to do with any direction, and multiplication of two numbers is having the commutative law to hold true. So therefore this is also true in case of dot product. Let's take a small example that if they are in terms of their ijk components, as I have chosen a quick example, A is having a1i plus a2j plus a3k and B is having b1i plus b2j plus b3k, then A dot B can be written as like this. Now remembering that I dot j or k will give 0, so let us directly take up this two terms, I with I, j with j containing term and k with k containing term. So you have a1 b1, I dot I is 1, no need of writing 1. Similarly a2 b2, j dot j is 1, and similarly a3 b3, k dot k is equal to 1. So very easy. It is to find out the dot product, simply the similar terms are to be multiplied. Further, you may be asked that find theta or cos theta. As A dot B is equal to AB cos theta. So A dot B, just now we have seen A1 B1 plus A2 B2 plus A3 B3, and magnitude of A is root over A1 square plus A2 square plus A3 square, and magnitude of B will be root over B1 square plus B2 square plus B3 square into cos theta. Therefore, if cos theta is to be found out, we can take care that cos theta is a1 b1 plus a2 b2 plus a3 b3 divided by the magnitude of the first vector and the magnitude of the second vector as like this. Don't remember it as a formula, just remember it as a working rule and you will be able to understand the logic of this dot product. Let us learn quickly and have a review of the cross product of two vectors. If A cross B is written like this, so it has a magnitude as well as a direction. It is magnitude of first vector into magnitude of second vector into sine of the angle between them. You can also write as AB sine theta. Now what is the direction? If you move your or stretch your right hand fingers towards first vector A and rotate it towards the second vector, the thumb points towards A cross B. That is, you can say that the direction of A cross B is perpendicular to both vector A as well as vector B. The resultant is perpendicular to both A as well as B. So in that way, I cross J is equal to K. You can remember like this, just draw a circle, put I, J, K and give this direction. I to J, J to K, K to I. So remember like this, I cross J is equal to K, J cross K is equal to I and K cross I is equal to J. If you rotate in the reverse direction, it will be negative. For example, I cross K will be minus J, J cross I will be minus K, like that. And for a quick finding out of the value of two vectors if they are given in terms of ijk, let us say A and B are given as their components and A cross B will be. It will be a tedious task if you write like this. So it is used in a determinant form. Just put it like this, two bars, there will be 3 rows, horizontal lines, 3 columns. In the first you put ijk. In the second line, you just put the 3 components of the first vector, a1, a2, a3. In the next horizontal line, write the 3 numbers b1, b2, b3 of the second vector. Now, this is a determinant. It is a determinant of 3 by 3 size. Now, in order to find out the value of this determinant, we need to expand it. Now, how to expand this determinant? Just observe the expansion. You first take the first row. First row, first member is I. Now, if you leave this first and the second row, what you are having this much? So just pick up this and put a small size determinant A2, A3, this is A3 and this is B2, B3. So first line you took out I. Then you pick up J. Whenever you pick up J, put a negative sign. Don't forget to put this negative sign here when you are taking J. Now in the row and column in which J is present, if you leave it, you have these two exactly in that same order. You pick them and make this small size determinant. After J you are having K. So with K, the row and column in which K is present, if you leave, you have this. Just pick up and form a determinant A1 and B1, A3 and B3. Now these are small size determinants. You have to expand it. Always remember, you have to multiply this way minus multiply this way. That is, this direction multiply minus this direction multiply. Don't remember any formula, just remember the rules. So now what it will be? A2 B3 minus B2 A3. I is there. Don't forget to put the negative sign again for this because it will be maintained like this. Now it is A1 B3 minus B1 A3 J. And similarly, the third one will be equal to A1 B3 minus B1 A3 K. So I will advise not to remember it as a formula, just to have a quick revision of the rule of this is the concept of finding out cross product. And in case of cross product, if the vectors are parallel to one another. If the vectors are parallel, that is having the same direction, then the cross product becomes 0, because sine theta will be involved in cross product. Let's see the other one. The scalar product of three vectors, that is the scalar triple product. The scalar triple product, why it is called scalar triple product? Because three vectors will be involved, a, b, c, and it is written as a dot b cross c. The result will be scalar. The result will be scalar. Let us have an idea that what is the meaning. See, B cross C we have to find out. What is B cross C? Imagine I draw B and C. And what is cross product? You have seen. The magnitude of B cross C, it will be equal to B into C into sine of the angle between them. Let us say alpha is the angle between them. So this is BC sine alpha. Now if you see the top view, just as a rough idea, this is B, this is C, and you have drawn a parallelogram containing B and C. This is alpha or theta, anything you want to write you can take it. Now magnitude of B cross C, just observe BC sine alpha. What is B? B is the base of this parallelogram, if you consider this as base, and C sine alpha is the height of this parallelogram. Very easily you can understand. So basically BC sine alpha, it represents the area of the parallelogram formed by the two vectors which are B and C. Area of the parallelogram. So what is the geometrical meaning of cross product? The geometrical meaning of cross product is it represents the area of the parallelogram that is being formed by these two vectors. Now try to understand. What is A dot B cross C? A dot B cross C is magnitude of the first vector into magnitude of the second vector into cos theta, where theta is the angle between these two vectors. Let's identify where is theta, where is B cross C. You understood that B cross C is this. B cross C is perpendicular to both B and C. So B cross C will be perpendicular to the plane containing B and C. B cross C will be perpendicular to the parallelogram formed by B and C. And the angle between B cross C and A is angle theta. This is angle theta. Now further, what is A cos theta? Just from A, draw a perpendicular on this. So everybody can understand if this magnitude is A, so this is A cos theta. And what is this figure we are having? This figure is having 6 faces. Each face is a shape of a parallelogram. So this is called parallelepiped. And for this parallelepiped, the base is a parallelogram because each face is parallelogram. And this is the height of this parallelepiped. What is the height? A cos theta. So now what we have is A dot B cross C is magnitude of B cross C is area of the base into A cos theta. Now what is A cos theta? Just now you observed A cos theta is the height of this parallelepiped. This is the height into height. So area of the base multiplied by height, it gives you the volume of the parallelepiped. Which parallelepiped? Which is formed by the three vectors as adjacent sides. Area multiplied by the area of the base multiplied by the height, it is volume of the parallelepiped formed by the three vectors as adjacent sides. So please remember that the geometrical meaning of dot product of three vectors, scalar triple product we call it, which is A dot B cross C, is volume of the parallelepiped formed by these three vectors as adjacent sides. Now, if all the three vectors A, B, C lie on the same plane, means A also lies on that parallelogram formed by B and C, then what will happen? There won't be any three-dimensional figure. So the scalar triple product becomes 0. The volume of the parallelepiped formed will be 0. This is one of the best condition of showing three vectors are coplanar. So when you have to show the three vectors are coplanar, You take any of them as A, any of them as B, and any of them as C, and perform A dot B cross C and show that it is 0, you will find that that is the best condition to show that the three vectors are coplannar. Just a small uh, analytical discussion. Let's say when A, B and C are shown like this in their rectangular components. So A dot B cross C, you don't have to find out B cross C and again perform the dot product. Just put a bar. It is determinant form of writing, of representation. In the first row, write all the three coefficients of the first vector A1, A2, A3. In the second, you write all the three numbers B1, B2, B3. In the third, you write C1, C2, C3 of the third vector. Now it is very easy, no IJK term. Pick up the first one member, A1, then the row and column in which first is A1 is present, leave it and form a determinant with B2, C2, B3, C3. Again, when I pick up the second one, with a negative sign, we will put this A2. Then the row and column in which A2 is present, you leave it and pick up the numbers and form this determinant. Again, you pick up A3 and the row and column in which A3 is present, leave it. It will be equal to B1, C1, B2, C2. Then as it is, the expansion will be multiply like this, again multiply like this. And therefore it will be A1 into B2 C3 minus C2 B3, and then it will be minus A2 into B1 C3 minus C1 B3 plus A3 into B1 C2 minus C1 B2. And do not remember it as a formula, just keep in mind as it is a working rule like this. Now you see one basic point, projection of one vector along another vector. How to project it? Suppose you have vector A and you have vector B, and theta is the angle between them. If you draw a perpendicular on this, so this is the projection of B on A. The projection of B on A, projection of one vector on another vector. Just keep on observing. I just put a heading. I was going to discuss parallel vectors. I already discussed that. Projection of one vector along other vector. These are two vectors A and B. Theta is the angle between them. I just draw a perpendicular. This is projection of B on A. Now what is this? From this triangle, this will be nothing but B cos theta. Is it not? The length of projection, it is equal to B cos theta. Length of projection is B cos theta. But B cos theta in which direction? B cos theta, it is in the direction of A. Now let's check. Projection of one vector along another vector is always a vector quantity. It is not a scalar quantity. Projection of a vector along any other direction is always a vector quantity. Now how to show that? B cos theta is the magnitude. If B cos theta is in the x direction, I would have mentioned B cos theta I. If B cos theta is in the y direction, I would have mentioned B cos theta unit vector j. If B cos theta, whatever the value, it is in the z direction, I would have put this much k. But B cos theta along A, that means I have to put a unit vector along A. Now what is unit vector along A? Any vector, if you divide by its magnitude, a vector A divided by its magnitude, what will you have? As a value you will have 1, but direction cannot be divided. Direction will remain as it is. Therefore, this is unit vector along A. Now what we have, just observe. B. What is cos theta? Cos theta is A dot B divided by AB. And this is A by A. Here you are able to see B gets cancelled and we have A dot B. A dot B just a number times A divided by A square. A dot B times a divided by a square. Please see and observe that this is the projection of which vector? This is the projection of b on a. If somebody asks what is the projection of a on b, then what will you have? The projection of suppose a on b, it will be equal to a dot b on b. So it will be b divided by b square. There is no sign here. There is no dot or cross because this is just a number. This number, suppose it's 5. So 5 times b divided by b square. B square means the magnitude of b whole square. That's the logic of this.